Welcome, y'all. Back to some Algebra 3. We're talking about linear equations, functions, zeros, and application. Now, this right here, the reason there wasn't a video before is because this is just practice problems based off what we learned in 1.4, how to make a linear equation. We were making linear equations. Now we're going to put those to use by solving for problems. So, for example, here, if I were to ask you to solve this, and some of you guys were in class to do that, some of you guys were not. We're just solving for y. So we always try to get the smallest side over. So minus y plus 7 plus 7. We end up getting those cross out right there and right there. I get 8 equals y. Simple as that. 2y minus 1y. So this is what we're doing. But we're going to add a little bit more complexness to it. So for example here, the Americans spent a total of $511 billion dining out back in 2006. That is a 5.1% increase over the amount in 2005. How much did we spend back in 2005? So with percentage problems, talk about this. Just think about it this way. There's a pair of shoes that costs $120. Let's start with the shoes right now. Now, it's at 35% off, okay? How much will my new cost? How much would it cost now? Most of us will want to find the 35%. So we'll say, all right, so we'll take 120 times 0.35. And I think you get 42. Let me double check. 120 times 0.35. 120 times 0.35. There you go. You get 42. Yeah, you get $42. And we think, like, all right, so that's how much is off. Now I'm going to go back and do 120 minus 42. You get 78. Which, again, right answer, not wrong with that. But there's an easier way to do this. Let's think about it this way. If I'm $120 is 100% of the original price. If I'm taking 35% off, I'm paying how much of the original price? 65%. So why don't I just take my $120 that I'm spending on shoes times how much I'm spending now on it? 0.65 or 65%. Oh, no percent. We do that, we get 78. That kind of takes a step out of this whole thing right there. So when we're doing a percentage problem like this, we got to think of how much over or under the 100% we're at. So for example here, 511 came from 2005's number. So X equals 2005's money. How much we spent in 2005? We took that times some percent and got 511. Now it tells us right here, we spent 5.1% increase over this amount. That means we spent a total of 100% of 2005's numbers plus 5.1% more. So then our total percentage is 105.1% of 2005's numbers spent. So instead of trying to do that, we're going to take, all right, Rx times 1.051. That should give us 511. Again, because this was 105.1% right there. So to solve for x here, we just divide both sides by 1.051. Get x to equal, let's see, 511. And you can do 511 because it's in billions. So 511 divided by 1.051. You get a total of $486.2 billion. So understand, when you have an increase or a decrease from a previous amount, either you're over 100 or under 100 by how much the increase or decrease is, instead of trying to find 5.1% of some number that we don't know. Now, other problems you'll run into are distance problem, motion problems beginning. So distance equals rate times time, hopefully. Rate of how fast you're going for how long tells us how far we go. So we have two different planes. We have a Boeing 737 that cruises at 500 miles per hour and a Dash A200 that cruises at 302 miles per hour. Okay, the Dash takes off at its cruising speed. An hour later, the Boeing 737 takes off at its cruising speed, taking the exact same route. Knowing that this Boeing goes way faster than the Dash, 198 miles per hour to be exact, it will catch up to it. How long will it catch up to it? So speaking of that, we're talking about how long. So let's kind of make two different equations right now. We got the 737's equation. So that's distance equals its rate times time. And then we got the Dash 8-200. Distance equals its rate times time. If we want to know how long it would take, what has to be the same here? Their distance. The value of the distance needs to be the same. That means this equation right here needs to equal this equation right here. But like it says, This has an hour start dash, so we got to add an hour to this equation for and them to be equal. So now as we set this problem up, we'll say 500t equals 302 times t plus 1. We'll distribute this value. We get 500t. The bell's about to ring here in a bit, y'all, so watch out for that. Equals 302t plus 302. Again, we got to get t by itself, so we'll subtract 302 to both sides. Minus 302t. We get 198t equals the 302. Divide by that. You get roughly 98t to equal about 1.52 hours or 1.5 hours. So there's the bell. I'm gonna finish this last one for you guys to have to look at in case you weren't. I haven't not seen you this week, which you guys are M through Z. I probably have not. Sorry, I miss you guys. All right, so we're talking about simple interest here. Simple interest is found by taking the principal, so how much money is invested into something, times the rate of investment for how long. So principal equals times rate times time gives us our interest that we make. Now, Jared here has 2 loans that total $12,000. One loan is $5,000. The other one loan is 5%. The other loan is 8%. They're both in there for 1 year. Now, it tells you how much interest you made in both of them. But here's the thing, like we said, we have 2 loans, 2 different loans. So we got to make 2 equations. So we got interest equals principal times rate times time plus another principal times rate times time. We have to increase another one. So as we set this up, we know what our interest is, $750. Now we don't know the principal of 1, so we'll call that x. We'll do that. That equals x. And now we do know the rate of the first loan, which is 5%. So 5%. And then it's in there for 1 year. Now we also got to make another one. This is loan 1. This is loan 2. The other one will be its principal. Now here's the problem. We can't bring in another variable. We can't call this y, because that will kind of mess everything up. But to guarantee that the amount that goes into this particular loan, loan 2, will total 12,000 with this is, we're going to say 12,000, the total amount, minus how much is in the first loan. So that's our x. There we go. Just we got to put a bracket on that because it's separate from that. Times the rate, 8%, times 1 year. So let's go ahead and simplify this. So we got 750 equals, now we're going to turn this to decimal, so it'll be 0.05, and that's times 1. So anything times 1 is itself. So it'll be x times 0.05, 0.05x. We'll fix that here in a bit. Plus the second one, this right here, again, gives us 0.08, and we're going to distribute that. We got to distribute that. So when we do that, let me see. I got to take my calculator too. 12,000 times 0.08. That gives $960. So when we distribute that, we end up getting $960 minus 0.08x. 0.08x. This kind of fixes up a little bit. So we got 750 equals 0.05x, the first one, plus 960 minus 0.08x. Now we have combined like terms, so we get 750 here equals the 960 minus 0.03x right there. Now here's the thing. We're looking for x, and it's going to look kind of odd because we'll get double negatives here. That's okay. So we're going to subtract 960 to both sides, minus 960. So 750 minus 960 should be 210. Not just 210, it'd be negative 210. Negative 210 equals negative 0.03. Common mistake that we make. When we move something right here, we just want to drop this negative sign. No, 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 no. Gotta keep that until you get rid of it officially. The official way to get rid of it is to divide by a negative. So to get x by itself, we're going to divide by negative 0.03 on both sides. In doing so, we got negative 210 divided by negative 0.03. You get a grand total of 7,000. X equals 7,000. So that is, the question is, how much would they put in each loan? Loan 1 has 7,000. Loan 2 has 5,000, because 7,000 plus 5,000 gives us 12,000. You'll have a problem similar to this. So hopefully this helps to kind of explain it. Where We've done something like this before, but it does add a little twist. So when we talk about two different loans, so we don't know how much is in each one, or this particular problem, we know one took off an hour early, so we got to understand, we got to compensate for that hour, or we're talking for a certain percentage over or under, instead of just like we're used to doing, finding the percent off or the percent extra and then adding it to the original number. That's not what we're looking for. Sometimes we're missing the original number. So hopefully this helps y'all. If you have any questions, let me know. Bye.